I had a question on how to go about number 8. Yeah, this one is super tough. This is much harder than what I'd put on an exam. But here's how you would do it if you had, 20 minutes. So here's our original problem, and we had one linear term here, not repeated, and then we have a irreducible quadratic term right here, and this one does have a repeat. So I set up a over x, and then I did linear, right, because we do constants over linear, and then we do linear over irreducible quadratics. So bx plus c over just to the first version, and then dx plus e, and that's to the second, to pick up both iterations of those factors. And then I used my LCD, which was x and then x squared minus 2x squared, and I use that to clear all those denominators, and I'll just say after you do that, you'll get right here. And I probably should turn the paper sideways because I kind of ran out of room a little bit. So we only have the 1, 0 at x equals 0. So even if I only have 1, I'm going to use that to get rid of at least one of these variables, because that's going to take me from 5 equations and 5 unknowns to 4 equations and 4 unknowns, which is a little bit of an improvement. So I let x equals 0, which knocks out everything on this side except for that 4. And then right here, that would be negative 2 squared made 4, and that's where I got 4a equals 4, so I got a equals 1. So with that, now I'm going to put that in right here for the a, and that went right there. And then I'm going to clean this up because this no longer has an unknown coefficient in the a, b, c, d, e variety. I can take this, FOIL it out, which I did right there, and then move all of this over to this side and get that reduced out. And so I kind of ran out of room, but hopefully you can kind of see what I did. I just recopied this down, and I'm subtracting all this over. And so when I go this minus that stuff, I get this right here. And then I just recopied this line down here. And then as I did that, I got everything in descending order because I'm going to want to match coefficients here in a second. So I went x4, x3, there's my 2 squared terms, and then there's my 2 linear terms. Just brought this down, brought those down, and then what I did here was I factored out that x squared out front just so I could see those coefficients a little bit better when I'm going to go match them up here to make equations. I did the same thing with that x. I brought that out front, and then that left me the 2c plus e. And then now I'm matching coefficients because I have this equation equals this equation, so that allows me to match up the coefficients for each of the terms. There is no x to the 4th term over here, so that's how I know b is 0 because it's not there. And then 1x cubed is matching up to cx cubed, so then that tells me that c is 1. And then for my x squareds, I have a coefficient of 1, and that's going to match. There's my x squared. So that's going to go with this negative 2b plus d, so this has to be 1. And by that same idea, then this chunk in front of, or behind, however you want to write it, on the constant term has to equal negative 2. And then back here, I already know b is 0 and c is 1. So I just went to the second equation and went, okay, b is 0 right there. And then that got me d was 1. I did that part right here. And then here I put the c equals 1 in there, and that was here, so that got me negative 2 plus e equals negative 2, so bring that over and I got e equals 0. So of these original 5 variables, a is 1, b was 0, so that dropped out, c was 1 right there, d was 1, so that'd be like a 1x, and then e was 0, so that dropped out. And then I just copied that down here, so hopefully you can see that. So yeah, that's a pretty tough one, but that is how you go about doing that, or at least that's one way to solve it. I think that was the easiest one I could come up with. You could skip this step and just go to setting it equal, but to me that makes a harder solve down here.